In the following video, we're going to look at a couple of examples on how to solve radical equations. And so in this first example, we have twice the square root of x plus 3 equals 0, and we're asked to solve this. And so the further you go in solving equations in math, you don't look at the variable when you're solving, you look at the object that contains the variable. And so right now, my variable is contained inside of this square root. And so what that means is I want to isolate this object first. Before I can even do anything with the x, I need to isolate the square root. Well, if I take a look, that square root's being multiplied by 2 and 3 is being added. So following how we normally solve, what I would do first would be subtract 3 from both sides. And then I'm going to get twice the square root of x equals -3. And so I'm still trying to isolate this object, and I see it's being multiplied by 2. And so what I'm going to do is I'm going to divide both sides by 2. And so I'm going to get the square root of x equals -3 halves. And so the square root of x equals -3 halves. And so where do I go from here? I have the object completely isolated, and so now what I want to do is get rid of the object that contains the variable. I want to perform the inverse operation. And so if we take a look, I have the square root of x. I need to get rid of the square root. And so what I'm going to do is I'm going to square the square root because that will cancel. And so if I do that to the left side, I'm going to have to do it to the right side as well. And so I get x equals, and -3 halves squared is a positive 9/4. But we're told we always want to check our answers. Like right now, our answer says x equals 9/4, but we have to verify that that's true. So you plug it in, twice the square root of x, so the square root of 9/4 plus 3. If it's true, should equal 0. Well, the square root of 9/4, the square root of 9 and the square root of 4 is 3/2. So I have twice 3 halves plus 3. Does that equal 0? Well, twice 3 halves, the 2 and the divided by 2 cancel, and so I get 3 plus 3. Does 6 equal 0? And that's no. 6 does not equal 0, which means that this x equals 9/4 is not a solution. You plug it in, it does not work. It's what we call an extraneous solution. So since that's the only possible value and it is not true, our final answer is a no solution. This is why it's important that you check your answer. You don't just stop when you get x equals. Because when you plug it in, it may turn out to be false. It may turn out to be an extraneous solution. And so we can't use that. Now the question I ask you now is, why is this an extraneous solution? Look at our steps. Something in our work should not make sense. Everything we did mathematically was right. But there should be some type of statement that does not make sense. And so twice the square root of x equals -3. Square root of x equals -3 halves. Now that, to me, sticks out. The square root of x equals -3 halves. Why does that stick out? Is if you take the square root of a number, it should always be positive. You can't take the square root of a number and have it be negative. So that, to me, sticks out on why we get an extraneous solution. So always keep an eye out if you get an extraneous solution, where in the work you should see it occurring. Let's look at example 2. 3x plus 5 equals x square root of 3. And so I notice here I have a variable on 2 separate sides of the equation. Granted, one of the variables is the coefficient for the radical. That's fine. But the bottom line is we always try and move the variables to the same side. And so we're going to do that here as well. What I'm going to do is I'm going to combine 2 steps into one. I'm going to subtract the x radical 3. So I get 3x minus x radical 3. And then I'm going to move the 5 to the other side by subtracting, so equals negative 5. Well, we can't combine them. Usually we move them over, hey, I can combine my variables, get them together, and solve. But if I look here, 3x, x radical 3, those are unlike terms. So the question we have to ask ourselves is, how do we get the x out of them? And what you do is, if you have x in two unlike terms that cannot be combined, what you do is you factor out the x. If you factor out the x, I'm left with 3 minus the square root of 3. I have x times this object, x times this 3 minus radical 3. And to get this x by itself, it's being multiplied by this parentheses, so I'm going to divide both sides by that parentheses. And here comes the tricky part. If I divide the left side, I have to divide the right side as well. And I said this is the tricky part because look what your statement says now. You have x equals, which is great. Your x is isolated, there's nothing attached to it, but x equals negative 5 over 3 minus the square root of 3. And what should stick out here is you have a radical in the denominator, and we can't have that. So I have to rationalize the denominator. I'm going to have to multiply the top and bottom by the conjugate of the bottom, which is 3 plus square root of 3. 3 plus the square root of 3, multiplied by a clever form of 1. So if I distribute across the top, I'm going to get negative 15 minus 5 square root of 3. If I distribute across the bottom, remember the whole point is to get the radical to cancel. And so what you're going to have is 3 times 3, which is 9, minus radical 3 times radical 3, so minus 3. If I distribute the 3 to the radical 3, I know it's going to cancel from here. That's the whole point of rationalizing. So all I do is take the first terms, multiply them, and subtract the last terms being multiplied. So 9 minus 3 is 6. Now we're not going to plug this in, but I will tell you for sure it does verify the solution. And so we saw some complicated problems here. We saw one with an extraneous solution, and we saw one where you actually have to factor out the x. Now remember, that occurs if your x is in two separate unlike terms. To get it out, you need to factor it out and then divide by the remaining factor. We will be looking at some more examples in the next video.